Hello and welcome to the Space Above Us. Episode 66, Space Shuttle Approach and Landing Tests. Last time, we took a detailed look at the Space Shuttle orbiter. We took a quick trip through the propulsion system, including the complex plumbing of the main engines, the far simpler OHMS engines, and the dozens of RCS thrusters. We touched, carefully, they're fragile, on the innovative silica tiles that made up the thermal protection system. We walked the wings, inspected the payload bay, and took a tour of the crew cabin. Though even with a full episode dedicated to learning about the orbiter, we barely scratched the surface of its technical intricacies. In time, we'll become familiar with every nook and cranny of this iconic spaceplane, but for now, we at least have a firm foundation to start from. And we're not the only ones who needed a solid foundation on which to find sure footing. In 1972, the design of the shuttle had mostly been worked out. The funding had been granted to actually start building it, and NASA got to work. But here's the thing. NASA had never built a space plane before. Sure, they'd built a few spacecraft, but this whole flying thing was new. Okay, maybe that's a bit of an exaggeration. After all, the first A in NASA stands for aeronautical, and they had run or participated in numerous studies on exotic aircraft, including the X-15. But it was still true that not NASA, or anyone else, had ever flown a winged vehicle down from orbit to a runway landing. When it was finally time for the first orbital test flights, planned in 1979, no one wanted any surprises when it came to the actual flight characteristics of America's new spaceship. Enter the approach and landing tests. The shuttle, despite arguably being the most magnificent flying machine in history, didn't really fly so great. The problem was that the delta wing that was required to generate sufficient lift at high altitude wasn't ideal at lower altitudes. The term I've heard most often to describe the shuttle's handling is brick. The glide slope angle, the steepness of the shuttle's approach, is a staggering 20 degrees. When you land in a typical modern passenger jet, you're looking at more like 3 degrees. At 20 degrees, it basically feels like you're flying straight down. Add in some input lag and some unusual characteristics due to the delta wing, and you've got a pretty tricky bird to fly, and there isn't much room for error. With no engines, there's only one shot at landing, and it's not until around 1,800 feet that the commander finally pulls back on the control stick, starting to flare the spacecraft and bringing it in for a nice, gentle 1.5 degree approach. Well, gentle-ish. All that momentum doesn't just go away, so the orbiter comes screaming in at over 200 miles per hour. So like I said, nobody wanted any surprises when the shuttle first arrived back from orbit. NASA needed a way to test the orbiter a little closer to home. And to do that, it needed an orbiter ahead of schedule. So let's meet OV-101. OV-101 is the official designation for the spacecraft that we will be discussing today. OV stands for Orbiter Vehicle, and the 101 tells us about its intended purpose. Since the first number is a 1, that means it was intended for orbital spaceflight. Since the first number is a 1, that means it was intended for orbital spaceflight, as opposed to a 0 for a test article. Then the 01 means that this was the first vehicle, since apparently the orbiters are 1 indexed and not 0 indexed. But before OV-101 would have a chance to earn that first 1 in its designation, it would be put through its paces in a purely Earthbound configuration. The plan was to create a vehicle that looked like the orbiter and worked like the orbiter, but only during the final part of its mission, the 5 or so minutes before landing, when the shuttle would swoop around, line up with the runway, and make a precision touchdown. That meant that rather than the hellaciously complex Space Shuttle main engines, it had 3 SSME lookalikes sticking out of the back, along with a bunch of ballast to make up the weight. Instead of a tennis court of silica tiles protecting its underbelly, there were a bunch of tiles that sort of looked like the real deal. And instead of reinforced carbon-carbon for a nose and leading edges of the wings, fiberglass. But make no mistake, OV-101 was a real-deal orbiter. It ran the latest available orbiter software on its computers, used fuel cells to provide power, and had functioning control surfaces and landing gear. When OV-101 rolled out on September 17, 1976, it was the public's first glimpse at the future of NASA. The particular date for the rollout was not chosen by chance, but rather because here in the US, September 17th is, apparently, Constitution Day, and OV-101 was to be known as Space Shuttle Constitution. However, if you happen to be at the rollout, that's not the name you would have seen on OV-101's side. That's because of nerds. In 1966, America fell in love with a different spacecraft. One that was decidedly less aerodynamic, but had one heck of a propulsion system. The USS Enterprise, designation NCC-1701, and its distinctive saucer and engine nacelles proved to be a rugged and capable spacecraft for Captain Kirk and his crew. As it zipped around the galaxy, it gave the world a glimpse into a space-bound future that awaits us all if we decide to go for it. But maybe with a few more Klingons. It also pulled in millions and millions of fans. And those fans thought it would be pretty neat if NASA's next piloted spacecraft was named after the fictional spacecraft they all held so dear. So they got to work mailing hundreds of thousands of letters to the president asking him to help out. The president's advisors took note of this and sent a memo to President Ford recommending that he suggest a new name to the NASA administrator when they next met. So that's why, when OV-101 rolled out on September 17, 1976, the word Enterprise was emblazoned on its side, and why the crew of Star Trek were on hand for photo ops. Though it does remain unclear, at least to me, if OV-101 was officially named after the starship, or if it was conveniently named after one of any number of other notable real ships named USS Enterprise. Once they digested the whole Constitution Enterprise thing, someone attending the OV-101 rollout might have another question on their mind. If Enterprise was going to help test the final approach and landing, how were they going to get it in the air? Those engines on the back are just for show after all. Remember how last time I mentioned that the orbiter is huge for a spacecraft but not so big compared to a jumbo jet? Yeah, the plan was to literally mount the orbiter on top of a specially outfitted Boeing 747. That's right, just when you thought you were off the hook, I've got a whole new vehicle for you to deal with. The Shuttle Carrier Aircraft, or SCA. Don't worry though, it's not too complicated. NASA actually had two SCAs over the years. One bought from American Airlines in 1974, and one from Japan Airlines in 1990. The SCA actually made a contribution to aviation right off the bat by helping NASA study the wake turbulence left behind large aircraft, which can be really dangerous to small aircraft following them. At the end of the day, the SCA is basically just a normal 747 with a couple minor tweaks. They added 3 connection points with support struts to the roof, which attach to the orbiter in the same places that it would attach to the external tank. The horizontal stabilizer in the back has an extra vertical stabilizer on either side to keep the whole thing, well, stable. All the furniture was taken out, and some reinforcing structure was added inside. And since NASA can't do anything without covering it in instruments, they covered it in instruments. The SCA was actually acquired as an answer to the question, how do we get this thing back to the Kennedy Space Center? Barges work but are expensive, and it'd be a real hassle to get the orbiter from Edwards Air Force Base, one of the main landing sites and located in the middle of the desert, out to a barge on the water. It just turned out to be a convenient vehicle to have when the approach and landing tests came around. When the Soviets were inspired by, our shuttle with their look-alike spacecraft Buran, they had to strap a bunch of jet engines onto the back for their gliding tests. But all NASA had to do was plop Enterprise on top of the SCA, fly to altitude, and they were good to go. If this all seems crazy, like doesn't the space shuttle weigh a lot? Wouldn't it mess with the aerodynamics of the 747? 2 things. First, keep in mind that what also weighs a lot are hundreds of people, furniture, luggage, and enough fuel to cross the country. It turns out that when you take all that out and add the space shuttle in, or on, you actually come out lighter than normal. Second, it actually did take some work to convince decision makers that this was a good idea. One thing that helped seal the deal, along with plenty of wind tunnel data I'm sure, was a radio-controlled scale model of the configuration. The model was built by a NASA engineer who worked on elaborate RC planes as a hobby, and I would guess that this has got to be pretty high up there on the list of potential RC plane enthusiast achievements. Fun fact, the pilot of the SCA was a guy named Fitz Fulton, and we've actually met him before, sort of. Among his many claims to fame, including dropping the X-1, though not on Chuck Yeager's famous flight, flying a supersonic B-58 to 85,000 feet, flying the Mach 3 bomber XB-70 Valkyrie, and flying the nuclear-powered NB-36H, we know him as one of the B-52 pilots who dropped the X-15. Small world. The approach and landing tests started out pretty simple. Once Enterprise was securely mounted atop the SCA, they started with some nice, easy taxi tests on February 15, 1977. They basically just took the shuttle carrier aircraft out for a little drive around Edwards Air Force Base. This way they could make sure that the combined structure was working as planned and that the 747 brakes could handle it. If you're wondering why these tests were done at Edwards, it's the same reason most tests like this are done there. It's a huge open area with nothing around and a nice flat dry lake bed to land on. No runway required. After the successful taxi tests were 2 weeks of inert captive flights. They were captive since Enterprise would remain firmly attached to the back of the SCA for the duration of the flight, and they were inert because the orbiter would be left unpowered and uncrewed. The goal here was to make sure that the mated configuration handled as expected in the air and at speed. Since the orbiter wasn't doing anything other than being heavy, pushing air around, and looking cool, there was no need to risk putting a crew on board. The 5 inert captive flights wrapped up on March 2nd, having attained a maximum altitude of 30,000 feet, maximum speed of 474 miles per hour, and a longest flight of just over 3 hours. The next flight, the first of the active captive flights, wasn't for another 3.5 months, so that gives us plenty of time to introduce our approach and landing test crews. All of these names are either ones we've heard before or will be hearing again soon, so I'm going to do a really abbreviated version of the usual biographies. Flying as commander and pilot in the first crew is Fred Hayes and Gordon Fullerton. Hayes, of course, served as lunar module pilot on Apollo 13. We last saw him aboard the USS Iwo Jima after the successful return of Odyssey and its crew, no doubt both grateful to be home and lamenting the lunar landing that should have been his. In fact, this wouldn't be the only time the moon was taken away from him. Though it was far from a sure thing, following the usual crew rotations, there was a good chance Hayes would have been the commander of Apollo 19. So instead of becoming the first human to land on the moon twice, Hayes settled in for the long wait to the Space Shuttle. Though he was originally in line to fly the second Space Shuttle mission, Hayes instead left NASA in 1979 for a career with Grumman. Alongside him for the flight was Gordon Fullerton. We'll be seeing Gordon again in just a few episodes as part of STS-3, so I'll save the full bio for then. But I will say that he, along with several other pilots we'll soon be familiar with, were what remained of the doomed man-orbiting laboratory astronaut corps. He flew with Hayes for 5 out of the 8 piloted approach and landing tests. Commanding the second crew was Joe Engle. We last saw Engle when he was flying X-15s over this very same stretch of desert. And if you go by the altitude requirements the Air Force uses, this will be the second winged spacecraft Engle will be flying. We'll see him again on STS-2. Joining Engle was another MOL astronaut, Dick Truly. Like many of the manned-orbiting laboratory guys, Truly had been sort of lurking in the background of our narrative for quite some time. The MOL astronauts knowingly joined a crowded roster, understanding that their shot wouldn't come until the shuttle. But in the meantime, they served as support crews, Capcoms, and other important non-flying roles. We last encountered Truly as Capcom on the Apollo-Soyuz test project, and we'll see him soon on STS-2. The 2 crews flew a total of 3 active captive flights. With the crew on board and the orbiter powered up, it was possible to run the computer and avionics through their paces before committing to a full flight. Once everyone was satisfied that Enterprise was performing well, it was time to get on with the free flights, where Enterprise would fly on its own. All of the ALT flights followed the same general pattern. With Enterprise firmly attached to the SCA and the Enterprise crew firmly attached to their ejector seats, the pair would ascend to around 20 or 25,000 feet, turn around, and then with the target runway several miles to the side, the test could begin. The shuttle carrier aircraft would pitch down 6 degrees, allowing Enterprise's wings to be at the proper angle of attack for gliding, and then prepare to slow down at the moment of separation to prevent Enterprise from striking the 747's tail. Upon separation, Enterprise would pitch up and turn to the right, while the SCA turned left below it. It sounds kind of like a stunt, but in practice it was one smooth and graceful maneuver. While reading the mission report for the first free flight, I came across one of those great little details that never makes it into a documentary, but that reminds you, hey, these are actual people who are really doing this with physical objects. Both the commander and pilot sat in ejection seats, which were kept in safe mode with a pin. The pin had one of those red remove before flight flags attached to it, so no one would forget to, remove it before flight. Well, on August 12, 1977, right before the first free flight, the crew discovered that 2 flags were on each pin. No big deal, except now when they were stuffed into their flight suit pockets, the flags were bulky enough that they might interfere with some of the controls. There's no mention of the solution, but I love that this detail made the report. Just when you think you've got every aspect of your incredibly complex spacecraft figured out, the crew's got pockets full of flags to deal with. At 6 a.m. local time, the SCA released its brakes and began rumbling down the runway. The first free flight test was underway. Once at altitude and on the correct path, it was time for Enterprise to finally spread its wings. The carrier aircraft dipped its nose, Fred Haise commanded separation, and Enterprise sprang into the air. A Space Shuttle orbiter was flying for the first time. There wasn't much time to celebrate, however, as with the crack of the explosive bolt still in the crew's ears, computer number 2 crashed, throwing a big X up on the display. The other computers picked up the slack, however, and Enterprise and the SCA parted ways without further incident. As Enterprise descended through 20,000 feet, Haise performed the landing flare maneuver to get a feel for how the vehicle would perform in a few minutes when he actually landed. This practice shot was the only real chance he would have for feedback outside of the simulator or training aircraft before doing it for real. It soon became apparent that Enterprise handled better than anyone had hoped for. The flight was smooth and easily controllable. 5 minutes and 21 seconds after separating from the SCA, Enterprise touched down on the dry lake bed at 213 miles per hour. The first orbiter flight was in the books, though the tests actually continued all the way up to wheel stop, with the crew evaluating the brakes and nose gear steering. Next up, a month after the first free flight, it was time to do it again. This time with Engel and Truly at the controls. ALT-2 focused on gathering data about specific areas of Enterprise's flight envelope. And with super pilots Engel and Truly flying the mission, they got a little creative. According to the excellent book Into the Black, the crew realized that both hand controllers worked at the same time. That is, if the commander tilted his left and the pilot tilted his right, nothing happened. They canceled each other out. In order to ensure the necessary data would be gathered in the limited window available, the two men worked together Pacific Rim style, with Truly leaving his stick pegged all the way to the right, while Engel blipped his through a series of movements designed to elicit the required vehicle responses. Now, I'm not a pilot, so I have no idea why this was helpful, but it sure does sound cool. Engel and Truly touched down safely after a 5-minute and 28-second flight. Only 10 days later, Haise and Fullerton were back in the saddle. Their 5-minute and 34-second flight doesn't seem to have encountered anything remarkable, which I suppose is a good thing, even if it's not very interesting. So I'll use this chance to mention that throughout these flights, the commander and pilot would trade off who was in control of Enterprise, ensuring that both astronauts got some time flying the spacecraft. It's also interesting to note that Mission Control back in Houston were looped in just like this was a real spacebound mission. With Engel and Truly back in the cockpit a couple of weeks later, ALT-4 started off with a slight change of procedures. During takeoff, the air-to-ground communications loop was left continuously open between the SCA and the engineers on the ground, monitoring its status in case of any unexpected flutter or buffeting. That's because this would be the first free flight without the tail cone. Wait, what tail cone? Ah, surprise! It turns out that the previous flights were sort of cheating a bit. There was concern about control disruptions caused by the inevitable turbulence generated by the various engine bells in the back of the orbiter. So to focus on the core flying characteristics, the early flights were flown with a large fiberglass aerodynamic tail cone covering the engine lookalikes. But the tests were going well, and it was time to find out how Enterprise really handled. On the way up, the crew checked the status of their controls and any potential buffeting that might occur from the additional turbulence. None was found, so there would be no problem proceeding with the test. It turns out that other than a few minor oscillations and a slight tweak in handling, Enterprise still flew like a dream, cone or no cone. On the way down, the crew evaluated Enterprise's performance at a few different angles of attack before lining up for a nice, gentle landing. I'm not sure if it was the lack of the tail cone, a change of approach, or due to the test performed, but this flight only lasted 2 minutes and 34 seconds. ALT-5, which proved to be the final flight, would change things up slightly once again. These tests were done at Edwards since out on the dry lake bed you can pretty much land wherever you like. That's great when testing an unpowered glider with unknown flight characteristics. But while some orbital landings were planned at Edwards, the shuttle was also expected to be able to stick the landing on the long runway at the Kennedy Space Center. So ALT-5 would attempt to land at a specific point on a specific concrete runway. Not the easiest task in a glider, requiring excellent energy management. This flight saw Hayes and Fullerton at the controls again, and the engine tail cone once more left behind in the hangar. As the 2-minute and 1-second final flight began on October 26, 1977, everything proceeded smoothly until moments before landing. There is a phenomenon in aviation that can be caused by sluggish controls. Let's say you're flying an airplane and you want to pitch down, so you push the control stick forward. And let's say nothing happens right away. You might push the stick further. But whoops, it turns out that the plane was listening after all. It was just a quarter second behind you. So the plane first pitches down and then pitches even more down. So you pull back on the stick, but again not seeing an immediate response, you pull even harder. Before you know it, you're in a frantic up and down motion that can quickly spin out of control. Welcome to pilot-induced oscillation. It's something all pilots have to deal with, and even when you know exactly what it is and how to deal with it, it's still a challenge. The shuttle was especially susceptible to pilot-induced oscillation. I don't know if this was ever changed, but at least for the early flights, there was something like a quarter-second lag between the control stick commands and control surfaces moving. As someone who's been known to play an online video game or two, 250 milliseconds sounds like an awfully long time to me. A pilot would have to be patient and disciplined to not immediately react to every little motion of the orbiter. And if that wasn't bad enough, due to its unique control scheme, it was possible for some commands to be disregarded entirely. If I understand correctly, the shuttle's computer could essentially be filled up with commands and start dropping new ones off the queue, 1202 program alarm style. So it wasn't the most shocking thing in the world when 8 seconds before touchdown, Enterprise began a pitch oscillation. The pitch oscillation soon led to a roll problem, and Enterprise was rocking and rolling a fair amount by the time it touched down the first time. The oscillation was bad enough that Enterprise actually lifted off again, wings rocking side to side before touching down again 6 seconds later. If you search online for Enterprise ALT-5 landing, you can see the fairly dramatic video. 7,930 feet after the initial touchdown point, Enterprise rolled to a stop, no damage done. Fred Hayes was pretty embarrassed by his final landing, but he shouldn't have been. Test flights are just that. They're tests. And it's often the case that an engineering team learns a lot more from failures, even mild ones, than from smooth sailing. With all 5 free flights a success, NASA had the data it needed and called an end to the approach and landing tests. Its crews moved on to other tasks, and so did Enterprise itself. OV-101 was used for fit tests, vibration tests, and to make sure that using the SCA to move the orbiter from Edwards to Kennedy, taking a pit stop in Houston, wouldn't pose any issues. Originally, the plan was to retrofit the first orbiter for spaceflight, hence the 1 at the start of 101. But it was not to be. The design had changed enough that it would have been far too expensive to update Enterprise, since it would have essentially required a complete rebuild. Instead, Enterprise, with a grand total of 20 minutes and 58 seconds of free flight time, rolled into retirement. For many years, visitors could view it at the Smithsonian Institution in the Washington, D.C. area. Though with the retirement of the Space Shuttle fleet in 2011, Enterprise's sister ship Discovery took that place, with Enterprise moving to the Intrepid Sea, Air, and Space Museum in Manhattan. The two vehicles briefly met on the tarmac of Dulles Airport. If spacecraft could speak, I'm sure Discovery, meeting its homebody sibling, would have some stories to tell. Next time, we're almost ready to go. I know, I'm as eager to get to STS-1 as you are, but there are a few odds and ends remaining. The approach and landing test proved that the space shuttle could stick the landing, but all that assumed it was able to survive the ride to space and the blistering trip back through the upper atmosphere. And what was the plan if something went wrong during ascent? What if some tiles fell off? Wait, tiles are falling off? We gotta fix that. I also suppose I should introduce the new astronaut class. Let's see. The last few were just a handful, so it shouldn't take too long. Here we go. Wait a minute. 35 new astronauts? Okay, we might have to change up our approach a bit. Ad Astra. Catch you on the next pass.